Welcome to The Explainer. We're diving straight into a really fascinating May 2026 paper by Tian Han. When I first read this, it blew my mind a little because it essentially builds a literal detective engine to hold major banks accountable for their climate risks. We hear so much about sustainability in finance these days, but when you actually sit down to read those glossy corporate reports, it's incredibly difficult to separate actual facts from corporate spin. Well, today, we're unpacking a breakthrough framework that's designed to change exactly that. So think about this for a second. Banks always claim they're managing climate risks, right? But what actually happens when we compare the risks a bank realistically faces against the problems they've actually fixed? Financial supervisors don't just want to know a bank's vague sentiment about the environment. They desperately need to evaluate the hard underlying exposures, the very specific responses the firm has put in place, and, most importantly, the remaining vulnerabilities left over once you match those two things up. To unpack this whole academic framework, we're going to follow a pretty straightforward roadmap. We'll start with the climate measurement problem, then look at the source addressed remaining framework. After that, we'll see exactly how GraphLLM works, go over the 6-point checklist, and finally, look at some real-world accountability. Let's get into it. Starting off with Section 1, the climate measurement problem, beyond cheap talk. Basically, right now, our tools for checking a bank's climate homework are fundamentally broken, leaving regulators pretty much in the dark. See, existing methods like those super opaque ESG scores or AI that just scans documents looking for positive sentiment really only measure a firm's stated posture. They mash all these signals together into composite indices where the rules are just completely hidden. And honestly, the scores diverge wildly depending on who's actually selling you the rating. What supervisors actually need are computable, cross-firm comparable, and, crucially, evidence-traceable answers. They don't need another vague score. They literally need the receipts. And this absolutely matters because climate risk isn't just one single thing. It's an intricate combination of three very distinct channels. First, you've got transition risk. That's the exposure to policy or tech shifts as we move toward a low-carbon economy. Then there's physical risk, which covers acute and chronic climate hazards. And finally, liability risk. Think litigation or enforcement coming from a firm's own sustainability claims. All of these dramatically different channels have to be measured uniformly under one single analytical frame, not just kind of clumsily stitched together after the fact. Which brings us to Section 2, source, addressed, remaining, the balance sheet of risk. This right here is really the hero of our whole explainer. You can think of this SAR framework a bit like an accountant's balance sheet, but for climate exposure. Instead of just parallel scoring, it does a residual computation. It's actually pretty elegant. You take this source of the risk, you match it up against how the bank claims that risk is addressed, and whatever is left over, that gap, is your remaining residual risk. By doing this, it makes all three of those components first-class outputs, completely shifting the paradigm of how we supervise these banks. So how are we actually doing this at an industrial scale? Let's get into Section 3, how GraphLLM works, lifting the hood. The massive hurdle we immediately run into is that the evidence is completely split across two totally different worlds. On one hand, you've got this messy, unstructured text, things like 300-page annual reports, transition plans, court filings. But then, on the other hand, you have highly structured data sets, regulatory registers, transaction databases, geographic hazard maps. The tricky part is, neither format alone can support a credible supervisory verdict, so we somehow have to fuse them together. To solve this mess, Han's paper proposes something really fascinating, GraphLLM. It's this incredibly powerful pipeline that combines a knowledge graph with a fine-tuned large language model. Its one singular job is to take all those chaotic PDFs and structured databases and convert the whole lot into a typed graph of factual claims. It literally standardizes everything into one single computable schema. It's kind of a huge game changer. Once it extracts all that information, the pipeline basically becomes a highly disciplined traffic cop. It uses a specific logic rule, what they call a predicate cluster decision, to rigidly sort every single claim into specific buckets. And there is zero gray area here. The system looks at the fact and routes it deterministically. Boom, done. Now, these sorted buckets end up forming two parallel universes of data. The first universe is the source subgraph, or risk graph. This is packed with potential risk sources, like the bank's operational geography, specific assets, or their counterparties. The second universe is the response subgraph, which is filled with the bank's actual stated mitigations, their governance strategies, and their metrics. So you've essentially got the problem totally isolated in one corner and the proposed solution isolated in the other. But here's where it gets brilliant. The way these two universes link together is that both parallel graphs map onto the exact same canonical entities, a shared vertex right in the middle. The system is smart enough to resolve surface variance, so it knows, for example, that Lloyd's Banking Group and LBG are the exact same thing. Having this shared middle ground allows the algorithm to directly compare the risk against the response to see if they actually align. Moving to section 4, the 6-point checklist, proving the response. Because let's be real, a bank can't just casually mention a risk to say it's handled. They actually have to prove it with structured evidence. This is where GraphLLM puts on its auditor hat. It checks the firm's response against 6 extremely strict dimensions. It's hunting for hard evidence. It asks, did they explicitly identify the risk? Do they have a board-level governance body overseeing it? Do they have numeric measurements? Are there clear time horizon targets? Is there external assurance? And finally, is the disclosure quality specific enough, or is it just corporate fluff? The system runs this exact addressing checklist to evaluate every single exposure it finds. It mathematically computes an addressing level based on those 6 dimensions to see if the response actually hits the required quality threshold or if it falls completely short. It's entirely replacing subjective human analyst vibes with a rigid, computable threshold. Now, if a bank fails this test, they get one of 3 failing grades. The first one is a missing residual. This happens when there is absolutely zero response chain found for an exposure, or maybe a mandatory dimension of the checklist is just completely absent. The risk is just sitting there, wide open, with nobody at the wheel. Building on that, the next failing grade is a weak residual. In this case, the bank at least tried to respond. There's some kind of chain present in their disclosure, but the hard evidence falls way below that required specificity threshold. It's pretty much the equivalent of a student giving a super vague, half-finished answer on a final exam, hoping for partial credit. And finally, we have the orphan residual. Honestly, I find this one the most fascinating. This specifically catches a response that has absolutely no matched risk source to back it up whatsoever. So essentially, the bank is loudly and proudly mitigating a problem that doesn't actually exist anywhere in the real exposure profile. As you can imagine, this is a massive red flag and a key indicator of potential corporate greenwashing. Which brings us to our final section, number 5, real-world accountability, testing the engine. So where does all this complex AI pipeline and graph methodology actually leave us in the real world? Well, the final output of all this is an undeniable supervisory residual. It generates a ranked list of graph fragments that identify very specific, unaddressed risks. But here's the real magic of the system. It's completely traceable. Every single finding links right back to the exact PDF page, the specific regulatory letter, or the exact dataset row that proved it. It totally eliminates the opaque, black box guesswork of traditional ESG scoring. And just to prove this isn't purely theoretical, the paper actually outlines a pre-specified pilot protocol. They're setting up to test this exact GraphLLM engine on the fiscal year 2025 disclosures of Lloyd's Banking Group, a massive UK retail and commercial bank. This pilot comes fully equipped with a rigorous 4-track validation design. We're talking human review, external corroboration against actual regulators, just to ensure the AI's extraction and matching are genuinely robust. As we wait for the quantitative results of that upcoming pilot to drop, it leaves us with one massive, incredibly provocative question. By shifting away from cheap talk and parallel scoring and moving toward a highly disciplined, computable residual framework, could an algorithmic, evidence-traceable knowledge graph finally force the transparency needed to end corporate greenwashing forever? It's a really thrilling look at the future of financial supervision, and for sure, it's a space we're going to be watching very closely. Thanks so much for joining us on this explainer.